Are you doing your math, Connie?
Yes.
Alright, quiet down, please. I know it's been a while because I wasn't here on Monday, and then we did this at the end of last week, so it does feel like a long time. But anytime we're adding two variables together, we can just add the means. So we have the mean number of cars sold and the mean number of cars leased. So to find the mean of the total number of cars, we would just add them together. 1.1 plus 0.7 is 1.8. To find the standard deviation, it's not quite as simple. You can't add standard deviations. You have to add the variances, which is why Zach squared them and then added them, and he got 1.298. So that's the variance of x plus y. So to get the standard deviation, he square rooted it and got 1.13. Yes, sir? Explain which part? I'm sorry.
Y squared.
Squared. So standard deviation is the square root of variance. Variance is not something we use a lot. We use standard deviation, but to find the standard deviation when you add or subtract independent variables, you have to add their variances. So we took our standard deviations. When we square them, they become variances. Then we add them together, and we get the 1.298, but we want the standard deviation, so we have to square root it. And then we get the answer we want. And I think one of you ladies has probably got the other part. Which one of you wants to go?
Julie?
Not that one. That. Which is correct. Paper, rock, scissors.
Oh wait, unshoot.
Oh my, what does it matter? What the order of the three
It doesn't,
things
but
are.
that's just how you say it, rock, paper, scissors.
Rochambeau. That's how you say it.
Do we round up the square root, or do we see
I think Rochambeau. Why?
1.144. Rochambeau
It's
is
like different. Alright, or different culture. What? It's just like it's from.
scissors, paper, rock.
What is that from?
Does it really matter the order? I'm
Yes,
becoming
it
all
does matter.
questioning myself, Noah. Okay.
Where we came from? Ireland.
It's rock, paper, scissors.
Rock, paper, scissors, shoot.
Why is there a shoe?
Paper, rock, scissors. And then it's also
Scissors,
called
paper, rock.
Rochambeau.
Scissors, paper, rock.
I don't know the name. I know it's called that. Paper, rock, scissors.
Oh, I see how you did that.
This makes me feel like I've been doing things wrong my entire life now.
Just rock, paper, scissors.
Oh, it's because in French it's
Wait, is
called
he gonna
rock.
be here today? Or is your kid still sick?
Here now, so
How's your kid about?
he's
She doesn't.
Say that again? No, he's acting totally normal. That's the biggest part that makes me like frustrated.
Mr. Bellsburg?
No, Henry, our 2-year-old. Good try. All right, so on number 3, the dealer gets a bonus $500 for every car sold. So what Anna did was she took the mean number of cars sold, multiplied it by 500, and then you get a $300 bonus for each car leased. So she took the mean number of cars leased, multiplied it by 300. So here's cars sold times the 500 bonus is 550. Cars leased times the 300 bonus is 210. And then because we're adding the two together, she just added the new means together to get 760. For the standard deviation, you multiply. So she took the standard deviation for cars sold times the $500 bonus, which gave her the 471.5. We can't add standard deviations, so she squared it to make it a variance. She took the standard deviation of cars leased, multiplied it by 300, the bonus, which gave her 192, but we can't add standard deviations. We have to add variances, so she squared it. So she has the actual numbers squared down here, and then she added them together, square root it, and you get a standard deviation of 50909. Questions? So today we're going to be doing the same sort of stuff, but we're going to be working with continuous variables still. So we're going to be drawing our normal curves, although not on this first one. We're just going to practice combining. And it's a payout problem. I don't know why you guys dislike the payout problems so much. You didn't like the lottery problem. You guys didn't like the insurance questions. It's one of the actual, most applicable things about statistics is figuring out the probability of payouts. How life insurance figures out if they're going to insure somebody or not. The whole lottery part, to me, that's just more fun. All right. So this says that most states and Canadian provinces have government-sponsored lotteries. Is that blurry to anybody else besides me? Okay. So here's a simple lottery wager from the Tri-State Pick 3 game that New Hampshire shares with Maine and Vermont. You choose a number with 3 digits from 0 to 9. The state chooses a 3-digit winning number at random and pays you $500 if your number is chosen. Because there are 1,000 numbers with 3 digits, you have probability 1 out of 1,000 of winning. Taking X to be the amount your ticket pays you, the probability distribution of X is payoff, so amount we win. $0, 999 times out of 1,000, which has the decimal is 0.999. I think I said 3 nines. And we win $500, 1 out of 1,000 times, or 0.001. Hi, Trey. Everybody good with our table and what it means? All right. So the expected value of winning is negative 50 cents for 1 ticket with a standard deviation of $15.80, which we don't have to do, but I'm just going to show you. if we were to put the payoff in list 1, so 0 or 500, and then our probability is 0.99, 0.001, and then we did our 1 bar stats with list 1, list 2. Why does it say, what did I type in wrong? This, oh, you know what I did wrong, sorry. I used the payoff, not the value of winning. But the standard deviation is the same. Because if you pay $1, you lose $1, or you win, you lose $1, or you win $4.99. There we go. A ticket costs $1. So this is the amount of winning. So you either win nothing or you win 500. When you take away the cost of the ticket, that would be your, you either lose $1 or you win 499. And they still have the same probabilities. So that's where that expected value and standard deviation came from. So suppose we buy one pick 3 ticket on each of 2 consecutive days. We're going to find the expected value and standard deviation for the total winnings. So first thing I'm going to do is I'm going to define a new variable because I'm buying a ticket for 2 consecutive days. So they say X is buying 1 ticket. So I'm going to define a new variable t. We tend to use t when we're adding to mean total, but you could use whatever letter you wanted to. So here's my ticket on day 1. And then I'm going to buy a ticket on the next day. So I use sub 1 for day 1, sub 2 for day 2. So to find the mean for the total, I'm going to take the mean of x1 plus the mean of x2. Now I'm playing the exact same lottery game, so the mean for x1 is negative 50 cents, or losing 50 cents. And the mean for the next day of playing the same lottery game is still losing 50 cents. So the mean that I would expect for playing the game 2 days in a row is to be that I lose $1 overall. So that's our expected value. Just to remind you, expected value and mean, they go together. Then to do standard deviation, we have to add the variances together, standard deviation of t. So we're going to take our variances for the first day, so that's our standard deviation for the first day squared, plus the standard deviation for the next day squared, and then we're going to square root it to get it back to a standard deviation. We're playing the same lottery game, so the standard deviation stays the same. So we're going to do 1580 squared plus 1580 squared, and then square root it. So we get 22.34 Yeah, that's a pretty simple example, but let's be honest, people who play the lottery probably play more often than just 2 days in a row. Anybody's parents play the lottery?
One time
I-
at 7-Eleven, there's this guy who's probably high on crack or something in front of me, and he tried to buy, he was buying lottery tickets, and his card got declined, so I let him use my card.
What?
That was
Okay.
nice
It was only
of
like
you.
$5. It was really nice, he was really funny. I tried using the bathroom, and the guy said no because it was past 10 and someone died of a heroin overdose. And the
Okay,
guy,
you're getting off on a huge tangent
It's happened
here,
in like 10
Hayden.
minutes. The guy who was on crack was like, "Hey man, let me see your arm. I know you just injected it there." When I came back.
That's why you don't go to 7-Eleven after it's dark.
Yeah.
All right,
Guys.
back to math. All I wanted to know was who played the lottery. I didn't want to know about crack and heroin and. All right,
Now what we have now?
His
so
name was Dominic.
so what I was getting at is that people who play the lottery tend to play a lot of times. So we're going to look at a different set of combining these variables. So down here it says you and a friend decide to play the pick 3 but with 2 different strategies. So your friend buys a $1 pick 3 ticket on each of 5 consecutive days. You bet $5 on a single number on your pick 3 ticket. Find the mean and standard deviation of the combined winnings for you and your friend. So on this one, I'm going to use the letter C just because it's different than what we're doing up here. I chose C because we're combining variables. Like I said before, it really doesn't matter what the letter is. So your friend is going to play 5 days in a row. So your friend is doing 5 days in a row. So we have the first day plus the second day plus the third plus the fourth plus the fifth. And then you decide that you're just going to bet $5 on a single ticket. So these ones represent your friend, 5 days in a row. And then you are just taking one ticket and doing 5 times as much. So when we find the mean for this one, we're going to do the mean of day 1 plus the mean of day 2 plus the mean of day 3, day 4, and day 5, plus 5 times the mean of x for just one day. So, like I mentioned with the previous one, it's all the same game, so the mean doesn't really change. Your friend is expected to lose 50 cents the first day, plus lose 50 cents the next, and 50 cents the third day, and the fourth day, and the fifth day. And you are just playing one day, but you're wagering 5 times as much, so you're expected to lose 5 times that 50 cents. And I apologize, the line kind of goes through some of my 5s and makes them look weird. So negative 0.5 plus negative 0.5 5 times plus 5 times the negative 0.5. Your friend and you are going to lose $5. You're expected to. Over the long run, that's what would happen. Any questions on finding the mean? Mean is nice and simple. Standard deviation, not so much. And that's what we're going to look at now. Any questions before I move on though? Alright. And of course I was a goof and I didn't leave much room for my big handwriting. So, to find the standard deviation of our combination, we're going to end up taking the square root. And there's going to be a lot of stuff under that, so I'm just going to leave it nice and long. So for your friend, we have to take the standard deviation of the first day squared plus the standard deviation of the next day squared all the way through day 5. And then, as Anna reminded us in the warm-up, when we multiply, we're going to multiply first and then square it. So this is 5 times the standard deviation of x, and then we're going to square it. And it does make a difference. Like here with the mean, adding negative 0.5 5 times was the same as 5 times negative 0.5. But when we have to work with variances, we want to square them, then add them. If we're multiplying, you multiply and then square, and it will make them be different values. So, let's see. I guess I'll write it out. So the standard deviation for your friend is just going to be 15.8 squared. And we're going to do that 5 times. Oh, come on. I could have made it 10 or 12 or a full month of playing the game. But I only chose 5 days.
There's just not enough room on the keyboard.
Turn it sideways. And then you are going to be 5 times 15.8 and then squared. And then, yes. So your friend, 15.8 squared plus 15.8 squared 5 times, that's 3, 4, 5. I'm sorry.
Wait, what does the last one say?
5 times 15.8 in parentheses and then it being squared. So your friend, when you add the variances 5 times, is 1248.2. You, on the other hand, when you do 5 times 15.8 and then square it, it's 6241. Big difference, okay? So adding 5 times or multiplying by 5 times actually are different when you're working with variances. Not so much in other math skills. So then we have the square root of 1248.2 plus 6241. 1248.2, and then I'm going to square root that. And so we get a standard deviation of 8654. I went to 2 decimals because it's money. We're looking at the amount of winnings. here. Questions? No? All right, now we're going to look at the normal distribution with these type of questions. So down below, it says, so far we have concentrated on finding rules for means and variances of random variables. If a random variable is normally distributed, we can use its mean and standard deviation to compute probabilities. That's what we did last class. An important fact about normal random variables is that any sum or difference of independent normal random variables is normal. So if both my variables are normal and I add them together, the resulting distribution is still normal. Or if I have two normal distributions and I subtract them, my result is still normal. So our example here is that Mr. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. If Mr. Starnes selects 4 packets at random, what is the probability his tea will taste right? So X represents the amount of sugar in a randomly selected sugar packet. So we're going to define T to be the 4 packets he picks. So that'd be the first packet plus the next, and the next, and the next. Because he's going to put 4 packets in his tea. We're going to figure out the probability that he got the right amount of sugar in there. So, to find the mean, we're going to add 2.17 4 times because we can just add our means. So we get the mean of 4 packets together is 8.68 grams. Standard deviation, we're going to take the standard deviation and we're going to square it, and then add the standard deviation squared again 4 times. So we're going to do 0.08 squared plus 0.08 squared plus 0.08 squared plus 0.08 squared, and then we're going to square root it. So we get, 0.16. Any questions on how I got those? So it tells us that Mr. Starnes likes between 8.5 and 9 grams of sugar. So really, we want to find the probability that T lives between 8.5 and 9. This is a continuous random variable, so to find the probability, we're going to work with a normal distribution. So we're going to draw our normal curve. It has a mean at 8.68 and a standard deviation of 0.16. be 78.84, right?
Yeah.
Thank you. And then when we add 16 to that, that'd be 9 even, right? And that one's easy, then it's 9.16. Subtract, that'd be 58, 52, 8.52. And then 42, 8.36, which then makes that 8.2. I guess I'll put the 0. So then we want to focus on finding the area between 8.5 and 9. So I'm going to say that's 8.52, so 8.5 is just going to be below it. And then 9 is right here. So I want to find that area. Normal curve. So we're going to use normal CDF. Lower bound is 8.5. Upper bound is 9. Standard deviation, mean of 8.68. Standard deviation of 0.16. 8.5, 9, 8.68, 0.16. So we get 0.8470 when we round. So the question was asking if Mr. Starnes selects 4 packets at random, what's the probability his tea will taste right? So 84.7% of the time, his tea is going to taste the way he prefers it. Yes?
Could you go over how you found the standard deviation again?
Yeah. So we're adding 4 sugar packets together. We can't add standard deviations, so we have to add their variances. So we're going to take the 0.08 squared and add it together 4 times. Am I in the glare of the light? So I have it added together 4 times, the variance. And then that gives me that. So that's the variance of t, but I want the standard deviation of t, so I'm going to square root my answer. Good? Okay. Any other questions? No. All right, now we're going to look at a subtraction problem. Scores on the ACT follow approximately normal distributions. Females have an average ACT score of 19.6 with a standard deviation of 2.3. Males have an average ACT score of 19.2 with a standard deviation of 4.1. Suppose that we randomly select a female and then independently randomly select a male and record both ACT scores. What is the probability that the female scored at least 2 points higher than the male? So we're going to define F to be the female ACT score. And then M will be the male ACT score. When we do subtraction problems, we use the letter D. I assume it's for the word difference, which is the answer to a subtraction problem. But again, I really don't care what letter you use if you're defining the letters. But if you see D, it tends to be because we're working with subtraction. Now, remember I told you order of subtraction matters. So we want to think through, do we want to do female minus male or male minus female?
Female, male, minus
Why did you say female minus male, Sam?
male.
No clue. You had a 50-50 shot and you went for it and you got it right. Well, actually, technically you can use either one. I prefer female minus male. Alex?
I was gonna say, so you can find a business for the males.
So I'm going to make up numbers here just to give a concrete example. Like I said, I like what Sam said, where our difference is female minus male. I want to find the probability the female scored at least 2 points higher than the male. So let's say, just for the sake of actual numbers, the female got a 24. That means the male gets 22 or lower, right? So my difference is a positive value. If I did male minus female, which you could do, let's see, I'll put it over here. Male minus female. The female gets a 24, which means the male gets 22 or less. I end up with negative values. Negatives throw me off, so anytime I can make sure I'm working with positive numbers, I'm going to. But like I said, you can do this one. It's just going to be, if you did it, the normal curve would be shaded on the opposite side of what I'm going to show you here. But I personally like to work with positives, so I'll figure out which way is going to give me positive answers. You will get the same answer either way though. I just like positives. So I'm going to define D to be female minus male. Now, to find our average difference, or the mean for D, we know that females have an average score of 19.6, standard deviation of 2.3. Males have an average 19.2, standard deviation of 4.1. Averages are nice and simple. We can subtract them. So to find the average D, we're going to take the average female score minus the average male score. So that'd be 19.6 minus 19.2, which is 0.4. Everybody good with that part? I just took female average minus male average. Then the weird thing about standard deviation is you don't subtract them. You don't subtract variances. You add them. So to find the standard deviation for D, it's the exact same thing. We're going to take the standard deviation of females, square it, so we're working with the variance, and then add it to the standard deviation of the males squared. And then square root it to get it back to a standard deviation. If you're adding or subtracting, standard deviation is found the same way. If you're adding to find the means, add them. If you're subtracting to find the means, subtract them. So here we're going to take 2.3 squared plus 4.1 squared, and then square root whatever that sum is. So we get 4.7. I took female standard deviation squared plus male standard deviation squared and then square rooted my answer. So our standard deviation for the difference is 4.7. So we want to find the probability that the difference is greater than or equal to 2. So we're going to draw our normal curve, shade the appropriate area, and then use our calculator function. That was a really bad normal curve, but we'll pretend it's good. So my mean is 0.4. I have a standard deviation of 4.7. 0.4, so that'd be 5.1, 9.8, 13, 14 and a half. Ugh, that'd be minus 4.3. I need to double check that. My brain's not working. 4.3, 8.3, so negative 9, negative 13.7. I feel like somebody was saying something. Is there a question? No? Alright, so this is the whole thing that I'm talking about with the positive or the negative. I define the difference so that when I subtract, it's going to be a positive value. So I'm looking at the probability the difference is greater than or equal to 2. So I'm going to say 2 is like, I don't know, there-ish. And I'm looking at that side. If I had defined it the other way and I ended up with a negative value, then I'd be looking at what's the probability that D is less than or equal to negative 2. And that would be pretty much the exact same area, just on the left, not the right. So you can do it either way. I prefer to work with the positive numbers. So that's how you'll see me do it, but it does end up that you can do it either way. So don't think if you end up with a negative, you did it wrong. So we're going to find the area here. It's normal CDF. Our lower bound is 2. That's this line right there. My upper bound, I don't have an upper bound. So I want it to go all the way through, so I'm just going to put a big number. 1e to the 99. Mean is 0.4, standard deviation of 4.7. Two, really big number, 0.4 and 4.7. So we get 0.3668 when we round. So about 36.68% of the time a female scores better than a male by 2 points. Yeah.
So we don't have to find like the z-scores for these ones? Just the other ones?
Technically no, unless it specifically says it. I just, like I said, we need to remind ourselves because it will show up on the AP exam. And so I will sprinkle it in here and there. If you want to do it, it's great. It's great practice, but technically no, you don't have to. All right, so oops, I didn't want my decimal there, sorry. And I'm going to be lazy and use symbols. So I just interpreted our answer. About 36.68% of the time, females score at least 2 points higher than males on the ACT. Females rock.
So that's the female symbol? Which one's the male?
Female, male.
Yeah.
Odd.
All right. Can I move it up? Last example we're going to look at. Leona. How would you pronounce that? Okay, that's what I thought too, but all right. Leona and Fred are friendly competitors in high school. Both are about to take the ACT college entrance examination. They agree that if one of them scores 5 or more points higher than the other, the loser will buy the winner a pizza. Suppose that in fact Fred and Leona have equal, this should say equal. Sorry, I type equation a lot, so sometimes I get on autopilot. Let's suppose they have equal ability, so that each score varies normally with a mean of 24 and a standard deviation of 2. The variation is due to luck and guessing and the accident of the specific questions to the students. The two scores are independent. What is the probability that the scores differ by 5 or more points in either direction? So, first thing, differ. So we're working with a subtraction problem. I'm going to use F to mean Fred. And the mean for Fred is 24. The standard deviation for Fred is 2. And then I'm going to use L to mean Leona. The mean for Leona, also 24. Standard deviation is also 2. So, it says that we want to find the probability that their scores differ by 5 or more points in either direction. So that means that Fred could score 5 points higher than Leona, or Leona could score 5 points higher than Fred. So in this case, because it tells us we're working with either direction, it doesn't matter if I do Fred minus Leona or Leona minus Fred. So anybody want to give me one? F minus L or L minus F?
L minus F.
Thank you. All right. So to find the mean, we're going to take Leona's average minus Fred's, which is 0. Which makes sense, right? Because if they have equal ability, the difference between their scores should be 0. Then to find the standard deviation, we're going to take the square root of 2 squared plus 2 squared. What's the square root of 8? It's 1.4, right? No, 2.8. I can't remember. 2 squared plus 2 squared, that is 8. Yeah. 2.8. So, now we're going to draw our normal curve. It's got a mean of 0, standard deviation of 2.8. That would be 5.6, 7.6, 8.4. And then over here, it's going to be the same numbers, just negative. Now here's the new thing about this question. It tells us that we don't care which person scores 5 points or higher. We just want to find the probability that one of them does. So 5 is like here-ish, and it's 5 or higher. So that would be if Leona scored 5 points higher than Fred. But there's also the situation where Fred scores higher than Leona, which would be -5 and lower. This is called a two-tail problem. We usually work with one tail, or we work in between numbers. Here we're working with two tails. The cool thing about the normal distribution is it's symmetric. So these tails have the same area, so I only need to find one of them and then just double it. So I'm going to find the area of this tail using normal CDF. Lower bound is 5. Upper bound is a big number. Mean of 0. Standard deviation at 2.8. Sorry, probably shouldn't cover that. 5, big number, 0, 2.8. So I get 0.0371 when I round. So that area is 0.0371. The symmetry of the curve tells me this area is also 0.0371. So to find the answer to the question, 5 points or more in either direction, I'm just going to take this answer and multiply it by 2. And we get 0.0742. So there's about a 7.5% chance that somebody's going to buy the other one pizza. Any questions on that one? I can't spell chance. Hate it when I let go and the whole paper just moves. Any questions? No? Alrighty. If you want to try the exit task, I like how you laugh at that, Hayden.
Nah.